So a quick update video on this LED panel that I'm working on, which is actually, this panel is from this toy purse. I bought another one because I wanted to use the screen from this one for something else. But that's it, running as it would be out of the box. But I just took the panel off and the controller that came with it, which is this one here. It's just a no-name blob on chip, or chip on blob kind of microcontroller thingy. I have no clue what this is or what it's running, so I just said, screw it, I'm not gonna bother trying to reverse engineer that. I'll just make my own. So that's the panel running off of this driver board here that I made. So it's using Arduino Nano as its brains, and the pins are going, or the pins from that are going through wires to a little these little male to female breakout pins that will feed into the socket for the panel back there. It's being fed off of 9 volts right now. Goes through the voltage regulator because from what I can tell, this panel is not supposed to be run over 5 volts, so I wanted to keep the voltage regulated. So it has a pretty large heatsink because it's the only heatsink I had that would actually fit, and all the ones I have otherwise are larger, so I need to get more heatsinks that are not as ridiculously big as that. But so that's the input voltage capacitor for the regulator. There's a thermistor there to keep it under 500 milliamps. On the back there is a can't really see it that great from here, but there is a reverse polarity protection diode. Over here is the buffer for the 5 volt output of the regulator, which is as close to the output for the panel as possible, just because that's how it ended up being. I used too small of a board. I should have used, I was initially making this, I should have used a bigger board like this one, but I had already made this, I had already soldered the Arduino to this board, so I decided, let's make it work, and it does work. Although I did change my mind a few times as I was making this, even though I did prototype it on breadboard. Just during the construction of this proto board, I changed my mind a couple times. So there are some components which are just sort of hastily put in there, like these 2 resistors. One problem I noticed is that when I had shut off the power to the Arduino, the capacitance between these two was keeping this board in a semi-active state. So when I started it up again, if I started it up too soon, it would lock up. And there were 2 issues with that. First, it wouldn't really respond to what I was trying to do if I was trying to set up a new program. But also, it would keep the screen on, but it would stay locked on a single row of pixels and just blast those at full intensity. So not only is it really bright, it might be damaging to these LEDs. I'm not sure what these are rated for. But it was pulling like, 200 milliamps or something ridiculous, because it was just blasting those LEDs at full brightness as the Arduino just sat there doing nothing. So you pull the discharge resistors for that capacitor in particular to just more quickly discharge the current or the voltage, or the charge rather, stored between those two to help it reset faster. The other resistor is tied to the output enable of the panel. So it's a pull-up to 5 volts because the output enable for this panel is an active low. So the issue is that, again, it would get stuck on one row and just blast those at full intensity. That could even happen as the Arduino was booting. So before the Arduino was even initialized, it would blast one row. So that pull-up resistor is there to just disable this panel until the Arduino is initialized. That's basically as simple as it is. In terms, all in all, the hardware is not that super complicated. It's the software that's complicated because you have to manually refresh every line of the display by yourself. So the Arduino is just blasting out data constantly to refill every single line, which also means that it has to keep the entire frame buffer in memory, so it can send it out every refresh cycle. So that's a lot of data to handle for this Arduino, but it seems to be doing okay. Even though it is running a pretty low frames FPS, it is slowed down artificially, so I could just watch it because otherwise it'd be moving pretty quick. But there's still some work I need to do. Like the bottom row here, the green row, is just random numbers that are filling in this row and then shifting it to the left. This top row is counting in binary on this row right here and then shifting it to the right. But you can see that the actual digits are not lining up with the respective pixels on the display. And that's because the pixels, in terms of the multiplexing, is staggered. And that's to help with the refresh. It makes it less noticeable that it's refreshing. But it also means that the pixels are misaligned. So in software, I'll probably need to go through into the update routine and change the order of the outputs and just try and make that work. But anyway, that's what I did during the Super Bowl.